is coming up on Wednesday. Yesterday, talked a little bit about the quiz that we took. Excuse me, the Chapter 4 test that we took. That'll be the last thing that goes into quarter two midterms. So I have the quizzes. I put those scores in. I still need to go back and correct the homework, so I'll be doing that. But the mid-quarter, the deadline is Wednesday, but then the grades are not due till Friday. So if there's anything that you want to make up, just make sure you're communicating with me this week so that you can get those grades updated into mid-quarters. I'll also be sending out reminder emails, trying to do that today or tomorrow so that you know what you're missing, but make sure you're checking your Infinite Campus so you can see what you're missing so that you can get those things caught up. So just taking a look at today. Today we have just a day to work on section 5.4. So we'll pull that up here in just a second. So looking at more points of concurrency. Today looking at points of concurrency with medians and with altitudes. And then tomorrow, mid-quarter. So that's just kind of the deadline for everybody. But the last score will be your quarter four, your chapter 4 test. And then Thursday will be our quiz on sections 1 to 4. So sections 1 to 4 will be our quiz. We do skip section 5. So if you're wondering why we just go to 5.6, we do skip section 5. So we'll go right into 5.6. Do you guys have any questions for me about the schedule? And you can throw them in the group chat on Google Meet or on to Go Guardian. Okay. Then you can go ahead and those of you who are here, you can turn on camera, so it kind of helps me so I can get a feel for what questions you may have or anything, so I can kind of do some inferences there. But we'll start with 5.3. We started to look at yesterday, and then some of you stuck around after our first part of class. And if you stuck around, we did a couple extra problems. But looking at section 5.3, I just want to get a pulse of from you guys. Are there any questions from section 5.3 that were causing you any issues that you'd like to take a look at? I feel like I like the hat. I just bought myself one of those. Used to have one as a kid, and then I can't find it, so I'm gonna get one. Very nice. Hayden, nice deer. Very nice. All right, welcome, Leighton. Good to see you. So 5.3, are there any questions that we have on 5.3? You can just throw them into the chat, and we can take a look. Then we'll take a look at 5.4, and on 5.4 then I will also do a little bit of the notes. So not a complete set of notes, but we will just talk about the two main segments from section 5.4, and then again kind of review what the point of concurrency is and how we can find the point of concurrency. So all in all, in section 3 and 4, we're going to have 4 different types of segments in a triangle, and then they each have their own point of concurrency. And then each point of concurrency is going to have different characteristics that are represented in the triangle. So yesterday, you had the point of concurrency of the perpendicular bisectors, and then that circumcenter was equidistant to all the vertices. Then you looked at the point of concurrency from the angle bisectors, and then the incenter was equally distant to all the sides of the triangle. Now today we're going to look at the point of concurrency with the medians, which is going to give us some segment breakdowns that we'll look at in a second, and then also the point of concurrency of altitudes, which is called the orthocenter. So first we're going to talk about what is a median. So a median on a triangle is a segment, which I'm just going to abbreviate SEG, that connects your vertice or a vertex to your opposite midpoint. So on each triangle, you have 3 vertices, you have 3 vertexes, and then on the opposite side, you can find the midpoint, which would just be finding the segment that splits your segment, or finding the point that splits your segment into 2 points. The median then is going to be that segment that connects your vertex to the opposite midpoint. Now there's some special things the median does. The median splits your triangle into 2 congruent, I shouldn't say congruent, 2 equal areas. So your median will split your triangle directly in half, because the triangles that you make have a base the same, and then they also have a height the same. So the areas are going to be exactly the same. So your median will split your triangle into 2 exact equal pieces. Next is going to be the altitude. So your altitude of your triangle, which I'm just going to abbreviate as ALT, your altitude is going to be a segment from vertex to a perpendicular on the opposite side. And we'll look at what that is here in just a second. But whenever you see perpendicular, so perpendicular, which also would be represented with this upside down T, but in a triangle, when you're looking at perpendicular, looking for that little box. So when you see that little box, that means you are dealing with some type of 90-degree angle. So that's going to give you a hint that you might be talking about the altitude. Now the median does something special when you find its center, and the center is called the centroid. So here my centroid is X. And what the median does is it splits each of those, centroid does is splits each of those medians into a 2/3, 1/3 share. So each segment is split into a 2/3 share and then a 1/3 share. The 2/3 is going to be on the vertex to the centroid, so that represents 2/3 of the length of the segment. And then the 1/3 is going to be from the centroid to the side, so that represents a 1/3. So we're going to take a look at CW here in just a second. So it says CW is equal to 15. Now I'm going to go to my diagram, look at where CW is, and CW is right here. So there's my CW. CW is a total of 15. Now we're throwing out this 1/3, 2/3. All you need to kind of think about is splitting 15 into thirds. So you're thinking about, what is 15 divided by 3? It's going to be 5. Now the CW is split into a 2/3, 1/3 share. So if CW, you split it into thirds, which means you have sections of 5. If 2 of those 5s are going right here, that means that CX is going to be 10. And then XW is going to be 5. And other things you'll notice is that the 2/3 share is always going to be exactly double of the 1/3 share. So your 10 and your 5 are going to represent the CX segment and then the WX segment. So it says find CX, XW, that's going to be 10 and 5. Next, we'll look at number 2. BX is 8. So looking at BX, I'm just going to highlight where BX is. BX right here is 8. So just from the vertex to the centroid is 8 right here. Now that represents 2/3, or it represents double this other share. So if BX is 8, that means that this little segment in here is going to be 4. It's going to be half of that. And then to find the full segment, b to y, I would add up 8 plus 4, which is going to give me 12. So bx is 8, xy is going to be 4, and then by is going to be 12. So I would just look at each of those segments. They're always just going to be that 2-to-1 ratio. So in each case there, we had 10 to 5, 2 to 1, 8 to 4, 2 to 1. So sometimes looking at thirds, we get a little kind of, fractions kind of freak us out. If we just kind of use that 2-to-1 ratio, that can help us to start to break down and find those different measurements using your centroid. All right, then to finish up, we'll look at number 4. We'll do number 4 together, just identifying a median and an altitude. So in my first diagram here, the big thing is I have a B, which is a midpoint by these two markings here. And then I'm going vertex to midpoint, so I'm going to say that is going to be a median. And then in the essence of time, I'm going to save some time by not putting the explanation, but from above, the definition of median would just be my explanation. I could just say it's a segment from vertex to midpoint. We'll go down below here. I see a vertex segment from vertex to this point right here, but is B our midpoint of that segment? No, so this one is neither. So that one will not have either or. We can slide over to here. I go vertex to a perpendicular right there. So that one's going to be an altitude. And lastly, I've got a vertex to a 90 degree. That would also be an altitude. Yes, Mason. Mason, you're up.